So we've established the gradient exists, right?
What's beyond the gradient is my question. I know if
What
you
do
don't
you
want to
mean
answer
beyond the
it,
gradient?
it's fine. Interrupt
What do
me
you mean
again.
beyond the gradient? What do you mean beyond the gradient?
Are my words not clear? What does
Yes,
beyond
words
mean?
not clear.
Should we
I have
break
no
on
idea.
beyond? Break down
How do you get
beyond?
beyond? How do you get beyond the gradient?
You're asking me another question.
Yeah, how do you get beyond the gradient? That's a silly question.
Are you afraid to answer the question?
No, I'm not afraid to answer the question. I just want to know what you mean by beyond the gradient.
Beyond, like there's here and then there's beyond, after. Like there's a border beyond the border, right?
Yeah,
You're in New York, you pass the border, beyond is New Jersey, right?
No, that's a line. There is no line. The gradient goes on.
You see the pseudo words that you
Nope.
see the hoops that you have to jump.
Nope, not hoops. You have to jump through hoops because you can't accept that there's a gradient.
I accept that there's a gradient, and I'm asking you.
Where's the gradient stop?
In your pseudo model,
SE?
you're interrupting every time I speak, right? Because you know what's coming, right?
Where's the gradient stop, SE? Tell me where the gradient stops.
In your pseudo model, it stops at around. Well, it depends. If you go by the American Air Force, it's 50 miles, and if you go by the Kármán line, which is the international recognized.
Kármán line.
You interrupt me every time because you don't want to go where I'm leading you. You don't want to go there because you're going to fall off a cliff when you go there.
There's still pressure at the Kármán line.
Okay, beyond the Kármán line. In your pseudo model, what's beyond the Kármán line?
There's still pressure beyond the Kármán line.
Okay, what's between the moon and the Earth in your pseudo model? Let's see if you can answer that one.
Pseudo model? I don't know what you're talking about.
Oh, you got reinforcements now. You got reinforcements.
So I mean, what's the? What are you talking about? See, I still don't get it. What's beyond?
You're playing dumb. You're playing dumb.
No, I'm not playing dumb. I need you to, because beyond means that the gradient. Where's the gradient stop? Where would you think the gradient stops? If you know the model, can you steel man the model to where it stops? Tell me where the gradient stops.
You see, you're skirting the question again. I rephrased the question to make it simple for you. What is between the Earth and the moon in your pseudo model?
Well, first of all, we got the atmosphere.
There's atmosphere there?
Well, I mean, you guys say it. You took the one thing where there's the very, very slight bit of hydrogen and said, oh, the Earth atmosphere expands beyond the moon. Remember that one?
I've seen Zanuck lights light up. I think he's here to rescue you. Zanuck.
I don't think any rescue needed. I mean, the question is always disingenuous, really. We all know that there's a gradient. I think NASA specifically said and asked you, where do you think it stops, and asked you to steel man it. No one has. And let's just say it really simply. We have an atmosphere. Air has weight. Hydrostatics is a known science in physics, and it starts out at 14.7 roughly, and it degrades exponentially as you go higher until you get almost nothing at a couple hundred miles away, where you're talking about a few particles every, 10, 15, 100 feet, all the way to the moon. Nothing.
And what do you call that in your pseudo model? A near perfect what?
A near perfect vacuum.
Oh, there it is. You hear that, NASA? At least Zanuck has the gut to say it.
Where's it stop, though? You have to tell me. So what do you mean by beyond? How do you go beyond the vacuum? That's the problem.
So I wasn't incredulous, right? Your model the way it is, your pseudo model, right?
The word beyond. So how do you go beyond the vacuum? That's the part that gets me.
You see what he's doing here, guys?
No, I'm trying to get your. Oh, by the way, did you know that if you go down in these deep mines, that the atmospheric pressure actually increases?
What does that have to do with your pseudo model and the near perfect vacuum?
Well, I'm saying that vacuum, meaning 10 to the minus 17 is near damn. We can only get, with all our technology and the scavenging cryo pumps and all the things we do. I was a part of that back in the late 90s. 10 to the minus 10. That was it. We're talking 10 to the minus 17 between us and the moon, and it's not much different than that anywhere else in the solar system, let alone the universe.
Well, it does. According to your pseudo model, it does get more. But NASA accused me of being incredulous, and I'm pretty sure that's correct in your model, right? In your pseudo model.
I just want to know how you go beyond the vacuum. That's the part that gets me. When you say go beyond, that's the part that.
You're still stuck to the beyond. It wasn't beyond the vacuum. It was beyond the atmos we were talking about. Beyond the Kármán line.
The Kármán line. There's still pressure beyond the Kármán line. Beyond the Kármán line. Where's the pressure? Where's the gradient stop, SE?
We're talking about statistics now at this point. Past the Kármán line, it's actually statistical. It's not just what pressure is, because pressure is this contact between particles, or between the actual measuring tool and a particle. And you may or may not get any contact for a while. In fact, what's between these particles is absolute zero. That's the part that a lot of people can't wrap their heads around. So as you get farther and farther away from the Earth and farther away from the moon, farther outside the solar system, the chance of you getting hit by a particle becomes very, very small. So that's why they have this 10 to the minus 17 and beyond reference to vacuum, because it's more of a statistical measurement than anything else. As you get lower and lower, it doesn't just stop, go absolute zero, because you might get hit by a particle, so they can't call it zero. It's statistics. You understand?
No one said anything about zero.
Well,
NASA didn't even want to say the word vacuum. He said I was incredulous. So thank you for clearing that up for him, Danik.
I want to know what you're talking about when you say go beyond the vacuum. How do you go beyond the vacuum?
Sea lining, bro. It wasn't beyond the vacuum. It was beyond the Kármán line.
Kármán
Stop.
line. Well, there's still
I told you there's
pressure.
pressure. I told you there's pressure beyond the Kármán line. Beyond the Kármán line is what 100 miles, 100 kilometers. So beyond the Kármán line, there's still 101 kilometers. There's still pressure. 100, not a lot, but some. You know, the Kármán line isn't some magic barrier, isn't some magic dome. You know, it's not like you go 1 inch below the Kármán line. There's pressure, and 1 inch above the Kármán line, there's no pressure.
Now you're gaslighting.
No, I'm not gaslighting. No.
So do you agree that in your pseudo model, there's a
model.
vacuum there? Are you going to admit that or no? Or are you going to still do what you're doing?
Well, what do you mean by pseudo model?
See that? It's unbelievable. He won't. It's like you're not even worth talking to, NASA. Like,
this
honestly,
you hate this, don't you? See, I'm just playing flat Earth against you. See, this is typical flat Earth arguments. You hate when I do flat Earth against you.
You're just gaslighting, bro.
No, that's a typical flat Earth response, though. Well, what do you mean by this? Because I mean, the other day I was asked, "What did you hate when I do flat Earth against you?"
You're just gaslighting, bro.
No, that's a typical flat Earth response, though. Well, what do you mean by this? Because I mean, the other day I was asked what to define. What was I asked to define? Define, was it? Or was something really dumb? Well, I know what it was. Arwin was here, and he wanted to say, "Well, now you have to define. You have to define R. You have to define this. You have to define." It was pretty funny. So when I do it back to you, though, you don't like it. Interesting.
Is my name Arwin?
Well, he's on your side. So anyway, when you still this part with beyond the gradient. I mean, where does the gradient stop according to your pseudo model? You know that you established there is a gradient, right? You accept that there is a gradient. What's it caused by on the flat Earth model, and where does it stop?
I didn't make any claims about any model. I was just referring to your model, and you don't even want to. You still haven't.
The Earth is flat. The Earth is flat.
Time, and it's like I don't even know why I'm talking to you.
According to you, the Earth is flat and not spinning. So how does the gradient occur? You established there is a gradient. You agree there is a gradient? Yes or no?
We were talking about your pseudo model, and I asked you about
what do you mean by
the near vacuum, and you're interrupting me. And you do it again, and I'm going to stop talking with you. It's that simple. I'm not going to waste my breath with you.
Kind of flowing. You guys are going back and forth. So he's not really being rude to you, I don't think.
Well, no, but he interrupts every time we speak.
You keep talking about pseudo model. That's what do you mean by that pseudo model? Is it a model or it's not? Not a pseudo model.
Hey, why do you call it a pseudo model?
Pseudo means fake
no,
model.
Pseudo doesn't mean fake. Pseudo means lots of different things. So pseudo doesn't mean fake.
Well, that's when I say it. That's what I refer to it. So don't ask me again. When I say pseudo model, I mean fake, incomplete. Look at it any way you want. Your model cannot exist in reality. In other words,
why can't it exist? Give me some reasons why it can't exist. For the reasons we give you that it does exist, what do you think is wrong about our description and the physics behind that we do know, that standard physics, nothing too elaborate, that would keep it or preclude it from existing? I mean, I'm curious as to your logic.
Perfect. Here it is. Ready? In reality, in physics, you cannot have a ball of gas in a near perfect vacuum.
That's incorrect.
All right. Can you steel man why you say there is a pressure gradient?
You're kidding me, right? You don't know. You think I don't know your model, your pseudo model?
You just said it's a pseudo. I know. I love this. Hesse, I love this conversation, by the way, and I'm really curious because you made a statement and you say that this gas pressure cannot exist in a vacuum. But you know our model says that the air has weight, and the weight is specifically telling us and is the reason for us to have hydrostatics. I mean, if you look at how hydrostatics works, this is the reason. When particles have weight, they're making collisions, the velocities are slightly greater going downward, you will have a hydrostatic effect, whether it's in water or whether it's in air or gases, and we see a exponential degradation of this pressure from the surface to the upper atmosphere, exactly comporting to the weight of these molecules. So it makes sense in our model. It's not a pseudo model because it makes sense that would occur. Now, whether it doesn't mean the Earth is round, it could be flat and still do this if there's some kind of magical attraction of these particles that gives air weight. But that makes sense. So you're the model. Why don't you tell us why do you think we have a pressure gradient? Like NASA asked you, what do you think the reason is?
Look, man, you asked me a question. You asked me why I don't think your pseudo model works, and I told you. But it is physically, don't interrupt me, man.
Right.
It is physically impossible for there to be a ball of gas in a near perfect vacuum. Now, if you can produce that for me without giving me just so stories of what you think and what should be and how gravity is, that's fine. You can believe it. Unless you show that to me, you have nothing except a belief.
Well,
except we have the Earth, itself, which is a sphere, measurably. We have the other planets that we can see through telescopes that have atmospheres that are spheres, demonstrably. What more evidence do you need? Are you like a Demok and you need like a little tiny planet in a bucket in a lab inside the Earth's gravitational well?
That's called affirming the consequent. That's
No, it's not.
Yep.
That's called making a hypothesis and finding data. It's not confirming the hypothesis. It's not based on logic. It's based on observational data.
Now, so I think he's got a point there, in that he doesn't want to hear us talking about things we see. They all could be fabricated. Just talk about what we actually do know. And yes, he can agree with us. We can actually send a balloon up, and with piezoelectric pressure sensors from Sunix, you can buy one for $50 and put it on a balloon and send it up. You will see the pressure degrade. So it follows suit, and we can also measure a container of water or air on the ground, and we can evacuate it, measure it, and we can see that air does have weight, and we can measure these things that we talk about causing this weight. And if it has weight, it would cause an atmosphere. So it makes sense what we've said, why the atmosphere stays dense and high pressure near the surface, and why it goes down to nothing, near nothing, as you go higher. In fact, you can measure nothing at some point, because like I said, it's more of a statistical measurement of these collisions. We can measure that. You know we can measure it. So that's our model. It's not fallacious. It's not affirmative consequent or anything. It doesn't mean that the Earth is round. I'm going to really go out on a limb there and say, it doesn't mean it's round. It just means that it could be flat or round or whatever, but if there's some magical force, whatever it is, it's there, magnetic, what's it said it is, hydrostatics or electrostatics, whatever. But we have forces that are keeping things, pressurizing the Earth and having an atmosphere that has a exponential degradation as you go higher. So why was that fantasy land when we all can measure this ourselves, SE?
You can believe whatever you want, right?
It's not a belief.
You can believe in pressure getting lower. But again, I'm going to emphasize this. Again,
you don't think it does?
It is physically, you're interrupting me again. Why, bro?
Because you're making errors in your assessment.
I'm not making any errors. I'm not making any errors. I'm telling you facts, physical facts. You cannot have a ball in a near perfect vacuum.
Forget about the ball.
You can believe that you can have that, but you're not going to convince me or most of the people listening. You're free to think what you want.
I've already said. I thought you were down. I already can see that it might not be a ball, but you're saying this whole concept of pressure near a vacuum is impossible when we can measure the vacuum. We can, every time you go up from downstairs to upstairs, you have a vacuum. Upstairs to 30,000 feet, you have a vacuum. 30,000 feet to 150,000 feet, you got a vacuum. I think it's 0.015 psi. Almost nothing. It's only at 100,000, 120,000 feet. Go into 20, 30, 40 miles, and you have basically zero. If we didn't have our accurate measuring equipment, it'd be zero. In fact, over time, depending on when you measure it, make the measurement, it will be zero. It's only occasionally you get an impact. That impact is why they get this 10 to the minus 17 torr. So you already measure it. There's already evidence for it. Both our cases have to support this degradation of pressure near a vacuum. Why can't you accept that?
Because it's not physically possible. I don't know how many times.
It is.
You
You take your cell phone. If you have a decent cell phone, it's got a barometer setting. Put it at your waist. Read the pressure. Raise it above your head. It will be lower. How much? What more do you need? Go up the stairs in your house if you have stairs. The pressure will be lower on the second floor than the first floor. Go down to your basement. The pressure will be greater.
That's some pretty amazing stuff. Really.
That's the gradient.
Look, man, you can believe in your pseudo model.
This isn't belief.
Don't try it. Look, if you're trying to convince me, it's not going to work.
Of course not. You're immune to facts.
Say whatever you want. It's not going to happen. You're free to believe in your pseudo model. I'm here to tell you it's physically not possible. It's that simple.
Wait, hold on. Do you have a cell phone?
No, I have a tin can.
Do you have a cell phone? Seriously.
What kind of a boneheaded question is that, man?
Simple. Do you have a cell phone? Yes or no?
Yes, I have a cell phone.
Is it a decent one? Does it have a barometer setting on it?
Huh?
Okay. Can you access that barometer setting?
Bro, go ahead. What is your claim? Make your claim.
Measure the pressure right now. Go upstairs in your house and read the pressure again. Notice that it is now lower than it was downstairs. That's the gradient. You've measured it. It exists.
Okay. And how does that work if there's a near perfect vacuum at the top of that?
Where does it stop?
You don't understand physics if you don't understand what I'm telling you. If you stop interrupting me, if you think there's some sort of magical, this is the last time I'm going to ask you, bro. If you think there's some sort of magical force that could keep the atmos next to a near perfect vacuum, you, again, for the last time, you can believe that. I'm here to tell you that's physically impossible. Don't try to tell me anything else.
You've just measured.
It's not going to work.
You've just measured the gradient. Hold on a second. You've just measured the gradient. Where do you think the gradient stops? Why would it stop? Where would it stop and why?
I'm done talking to you guys, man. It's like talking to a wall.
You've measured the gradient. You have personally measured the gradient with your cell phone. You've measured it at one location, gone up, I don't know, 20 feet, and is lower. You've measured the gradient. If you keep going up, it'll get lower. Where do you think it stops?
Essie, he's right, and you're just being incredulous. Seriously, we know that by virtue of air having weight, and we can have that discussion if you'd like. Just basic physics education here, and you're not stupid or anything or dumb or anything. It's just ignorance. It's just not knowing it, and we're trying to help you understand it. And it's by virtue of air having weight.
Stop with your idiotic stuff.
By virtue of air having weight, and you can measure it. That's why the gradient goes down, whether the Earth is round or flat. If we can't get past that square one, then we really have no business even talking about it, because that's the reason air has weight. That's what causes the pressure gradient.
That's right. You have no business talking about this. You don't even know what gravity is. You're gonna fall back to, again, you're interrupting me. You're gonna fall back to Newtonian gravity. Then I'm gonna tell you that it's been superseded by Einstein. It's like talking to kindergarten students, man.
It
is because the law
just wasted my time.
You don't even know the difference between the law and the theory. You're referring to the law as your argument, which is a fallacious argument. We're not talking. I mean, the theory. We're not talking about what causes gravity. We're talking about the gravity is what it is. That's the law. Newtonian measurements are perfectly valid for this discussion. We don't even know what causes it. We just know that it exists. If you want to say it's hydrostatics, electrostatics, magnetism, we don't care. It exists. We all know that it exists, and that is the reason that it exists. That's the reason why there's a pressure gradient.
And your Wittstedism about Einstein being superseding Newton is incorrect. Einstein supplanted or extended Newton. Newton is a subset of Einsteinian gravity. That can be proven. Because you can derive.
Wow, I never heard that before. Yeah, you just believe in a fantasy.
Now you're interrupting me. This is not. You can look, since I can't do it to you because you don't know math well enough. Go Google it yourself and look for the guys that basically take the tensor equations and from them derive Newtonian physics. It works. It's just as well. It's not a supplant. It's not supersede. It's extend thing.
I'll post
you can do all the tensor equations you want. You're still not going to change physics. It's impossible to have gas. A ball of gas in a vacuum. Nothing you say or do is going to change that. Nothing.
You've measured. What more do you need to do, Essie? You can measure with your phone. You can measure the gradient. The gradient exists. Where does it stop now? If it's lower on your second floor than is the first floor, and then lower on the third floor than is the second floor, go to the tallest building in Montreal and measure the pressure at the top of that. Where does the gradient stop?
Not next to a near perfect vacuum, because that's physically impossible.
But you're measuring it.
It would scatter in your pseudo space.
So
you're measuring it. No, it won't, because there's a downward force of some kind which we won't discuss right now. But there's obviously
you don't want to discuss.
Because there's obviously you've measured it. See, you've measured the fact that this something that there's a gradient in the atmosphere. You have personally measured it. Now you've got to figure out, according to whatever you want, why does it stop? Where does it stop and why?
I don't got to figure out nothing. All I got to do is tell you about physics, and the belief that you have measurement isn't going to save you. Gradient isn't going to save you, because
yes, it is. It should.
You're interrupting again. Because at the end of the line, what you think is physically impossible. I don't know how many times I have to say it. Repeat it.
Maybe we know something you don't.
You've measured the gradient.
And maybe if we want to reason out why this is happening, you could be part of the Flat Earth Society, and the Earth is accelerating upward at 9.8 meters per second squared, which would simulate exactly what we see on the Earth. It would give us the same gradient of the atmosphere and everything. However, we would be hitting light speed every year. Yeah. But that's physically impossible. That we do know due to physics. That we do know. You're saying that it's not possible to physics, but you're absolutely positively wrong, Essie. Due to physics, we are correct. Now, what causes this effect? We may not know. We could be wrong. It doesn't matter.
Well, you most certainly are wrong. You most certainly
you're just because you say we're wrong doesn't mean we're wrong. Essie, this incredulous attitude you have is really. I've never heard this out of you before. I mean, we've been spirited on this argument. Right now, you have no leg to stand on, and you're interrupting me. You have no leg to stand on. Yeah.
You've never heard of incredulity before? No, I've called him Essie incredulity for a long time, because that's basically his argument. Is all
he always has some leg to stand on.
When you resort to insults, it's
not insult. Essie, it's not insult. I'm sorry, it's not insult.
You're an intelligent guy. I can see why you're frustrated with this conversation, but you have to give us.
I'm laughing. I'm not frustrated at all. I'm laughing at you guys.
Well, you said I can't talk to you. So you said this conversation.
What's your evidence? What's your evidence other than I don't believe it, which is incredulity, by the way?
Yeah. And why do
the evidence is this: if you can produce gas pressure without a container in a vacuum, then you see you're laughing and interrupting because you know. Until
because
then,
you're being a DMOC now. DMOC,
until then, you have
spinning ball, water sticking to
like
it.
I'm gonna start. Nah, it's over. Like I'm not gonna talk and waste my time with you guys when you interrupt me. Have a good night. Believe what you want.
Not a belief. We already went through the simple, very politely went through the simple physics of why we understand how there is a hydrostatics in our atmosphere. The hydrostatics giving us a gradient atmosphere. And we even can see it. It can be flat. You don't want any bone I'm giving you. You're just frustrated because you think, oh, you keep on going back to maybe it's this whole Nathan Oakley thing. Oh, second law of thermodynamics, and him and QE going back and forth about gas pressure without a container. What they really mean to say is force. If there's a force, there can be gas pressure without a container. I mean, that's kind of a silly actually statement because there is containment. We have containment of the Earth. There is a container. It's contained by virtue of its weight. Air has weight. That's the containment.
So you're just preaching. You're just preaching your belief.
No, I'm giving you the
Which is
reasons.
fine. It's okay. No worries. Just don't try to convince me.
I'm not trying to convince you. I'm just giving you the information.
I don't need your information. I have my own information, and it is what it is, man.
You haven't answered my question. So if we have measured this gradient, and it does go near zero, as high as we can measure with kindergartens and their teachers setting a balloon up, we measure this gradient. What in your mind, following the physics that you seem to understand or say you understand, what would cause that gradient? Can you answer it very clearly and articulate your position of your understanding?
Take any container, put gas into it, you'll see a gradient. That's irrelevant. The fact of the matter is that you believe. See, this is the part you don't get, man. This is the difficult part for you. You believe in a fantasy. You believe you live in an area that is physically impossible. And you believe just by saying gradient and gravity, that's going to get you out of it. It will not. You believe in a physical impossibility.
Wow, I just got done telling you about what we both can measure, and we both don't have to know what causes it. But you're saying it has to have a physical container, yet we do measure it. So what if I give you this? I mean, I'm in a very giving mood tonight. I'll give you the container. We have a big dome over us. Does that make sense now? We have a dome.
I don't need you to give me anything, bro. You're trying
I'm not giving it to you.
You're trying to convince me of your pseudo model. It's not going to work, bro.
What if we have a dome?
Your snake oil to somebody else. It's not going to work.
If we have a dome, would that make sense?
No matter how you try to rephrase it or whatever question you try to ask me, it's not going to work.
Well, I mean, dude, so I can't win. I mean, you can't even win. If I give you the dome, would that allow us to have the gas pressure with the containment of a dome? Would that help you?
I don't want you to give me anything, bro. You can't
even answer my question. Okay, Essie, seriously, two adults having a conversation. Essie, please tell me what you think causes, based on your knowledge of physics, what causes the gas pressure gradient in our environment that we live in.
I already answered to you. Take any gas, put it in a container, you will find a gradient in it. That's the way it is.
No, that's not an answer. Anyone listening
well, that's too bad if you don't like that answer.
It's not an answer. You can't say that's affirming the consequent. It's like saying, why is the window open? Well, because the window's open. I mean, come on. It's really silly. You have to tell me how it's happening. I gave you some tools to work with.
I don't have to tell you anything, bro. I don't have to tell you anything.
I know you don't have to. So tell me what you can't say you can't have gas pressure without a container. That's not an answer. What do you think?
That is a fact. Show me some gas without a container.
You're interrupting me.
You can't do it. You're just going to bloviate.
You're interrupting me, Essie. You are. So please tell me, if we have this gradient that we measure, what do you think? And you can use whatever, give me any answer you want. What do you think causes it? Not we have a container and have air in it, it'll give us a gradient. That's not the answer.
I'm not going to go over this. I already answered you that.
I never heard it from you. Please.
I really don't care what you think, bro. Conversation's over. I'm done talking with you, man.
I won't be able to sleep tonight. I won't be able to sleep tonight.
It's like grade 5 stuff, bro.
I seriously want to know what you think causes this gradient, whether it's in a container that's on the table or whether it's a dome over the earth. What do you think causes the gradient? Please, I want your honest opinion. You don't got to be right. I really do. Seriously. You're going to ignore me. You're going to play hard to get. Yeah, this is how that always ends.
You're a waste of time, bro. You've been convinced.
I'm not. It's two guys talking.
You're
I'm curious
interrupting
as to
me.
your answer.
You're interrupting me. You're interrupting me.
All right.
You're a waste of time because I keep telling you.
You haven't told me.
You've been convinced that you live in a physical impossibility. You think you're whizzing around at 1.5 million miles an hour, doing all kinds of vectors, all this crazy stuff. You're pseudo model, and for some reason, you have the need to convince me
You're
of this.
gaslighting me.
It's not gonna work, bro.
You're gaslighting me. I haven't said anything
about
our
work. I don't
spin.
have to explain to you anything. All I have to show you is
Gaslighting me.
not gaslighting you. You're interrupting me. All I have to do is show you and anybody else listening that a gas ball is not physically possible inside a near vacuum. And that
Fine.
ends the conversation right there.
No, it
I don't
doesn't,
have to
because
answer any of your pseudo model questions, bro. End of
Okay.
conversation.
No, it's not, because that gets us to the next question. So what do you think causes the gas to have a gradient in it in our atmosphere? I mean, I don't care about the spin hurling through the atmosphere, the around the sun at 66,000 miles an hour. You go a million miles an hour through the galaxy, whatever. I don't need to know any of that. I don't need. You can have a dome. I'm giving you all the tools you need to give me an answer, and you still have not answered my question. Your answer was, if I put gas in a container, you have a gradient. That's not an answer. Why is there a gradient in a container? Why is there a gradient in our atmosphere? Can you answer me and articulate your belief or your idea with your understanding of physics, how it's possible? Because we do measure it. Please answer. I would appreciate it. This is where you talk. Okay? It gives me no answer. Oh well, I tried.
So I had to step away from the mic. What else we have besides the pseudo model? What else is going on?
Well, you've got Northern Rebellion, who's supposedly on your side, who just posted a video about great circle routes and stuff. That's kind of interesting. It's almost like you didn't watch what.
Great circle routes?
Yeah,
What does
he's
that have to
asking
do
why.
with gas pressure?
It has to do
Next
with
to a
globes.
container. Next to
Well,
a
it
vacuum.
has a little bit to do with that, and that the airplanes fly high because the air is less dense high. But this one has to do with great circle routes.
Well, I remember like 5 years ago, Blue used to tell me it was because of gravity that caused the plane to go around. Now you guys changed it to pressure.
Same difference.
Gravity and air pressure is the same difference? Okay.
Yeah, gravity causes air pressure. That's correct.
And which gravity would that be?
Gravity is gravity.
Yeah.
Yeah, just because Einsteinian
with less
and Newtonian gravity,
Newtonian have to work harder and burn more fuel, so it wouldn't be as efficient for them to do that.
Right. And Newtonian physics is a subset of Einsteinian physics. Anyway, this is funny that Northern published a basically globe evidence. Yeah, they don't fly over the Pacific Northern because it's a great circle route. He even do the string thing. Cool. I've been looking for a video that does that.
It's funny how you've been convinced that Newtonian gravity, mass attracting mass, and the fabric of space-time are the same thing.
Yep,
like this duality you guys hold is
not a duality.
Talk about being incredulous. Wow, man.
I know, but the fact that you can derive Einstein's equations starting with, or corrections, you can derive Newton's equations when you start with Einstein's equations. That's the part that should convince you, because
So you think doing a
proof.
bit of math? You think doing math?
Yeah, math. Yeah, math.
The
The language of physics. Yeah, math. The language of physics. That's correct. Yeah, the language of physics, math. Yeah, the fact that you don't do math should say something, because I mean, math is like physics.
Well, the fact that both of those gravities have been disproven by your own scientists, it's kind of comical to me, right? You think you can derive one for the other, but even the other one, the Einsteinian one, doesn't really work. So what now?
It does work. It works quite well. Thank you.
Yeah. You just can't see it, man. You're in a cult. You've been sold a lie.
I'm in a cult.
You just don't want to see it.
I'm in a cult. The one with the evidence. Yeah, the one that was trying to showing you your cell phone that you can measure that you personally, the scientific person you are, could actually do a science experiment and show that there is a gradient. And then I ask you a simple question like, where does the gradient stop? And you immediately have to go off and do pseudoscience, start doing Witsidisms and stuff.
I've been doing this way before I heard the name Witsid. I don't know why you're bringing it up. Did you have a dream of him or something?
No, because you keep using his phrases like Einstein. What Einstein? What was the word?
I've been talking about that way before I heard this dude, bro. I don't know why.
Then why don't you answer my question of what you think causes the pressure gradient?
Don't bother me, bro. Like I told you, don't bother me. I don't have to answer any of your pseudoscience.
You don't have to, but it seems like you'd want to, since everything we say is wrong and impossible. Yet you can't tell us what causes it. And when I ask you how to cause it, you say, "Well, you put a gas in a container; it always has a gradient." That's not giving me the answer. It's like circular reasoning.
Google it, man.
Oh, I know.
What I was talking about now is Newtonian gravity and Einsteinian gravity.
Same thing.
And I'm telling him,
the
Newtonian gravity is mass attracting mass. Now you've been convinced. First of all, that's been superseded. Number one.
Incorrect.
Wrong.
Let me finish. Number two, you've been convinced of this thing called time, right? And space combined to make the current gravity. It's like, how can you talk with somebody like that? Like, how can
you know what? Let's say I don't even believe that.
Time and
let's say I don't
space
believe any of it. I'm
combining
asking your opinion.
to make gravity.
All you can tell is everybody how wrong they are, but you can't tell us what your opinion or what your belief is or what your understanding is. Based on your understanding of physics, whatever year you want to base this idea about, back in the 10th century, I don't care. What do you think causes the hydrostatic phenomena called this atmospheric gradient?
You want me to say gravity? That's what you want.
No, I don't care what you say.
That's what you want to hear.
I truly want to know your opinion. What do you think causes? I mean, when you go to bed at night and you lay down and go, you know what? This atmosphere is caused by such. Tell me what that answer is in your mind.
Ether pressure.
The atmosphere is...
Fine, good answer. Fine, I'll take that.
What was that?
Someone said ether pressure. What do you think it is due to, SE?
The amount of it.
Fine. But what do you think is causing it?
Obviously, that's an obvious answer. You have gas produced at the bottom. You have gas produced at... This is an elementary thing, bro. You have gas produced at the bottom, and it rises slowly. It's very simple. It's buoyancy.
If there's no downward,
I got a bunch of information here. If it rises slowly, so therefore we have a gradient. I don't. How does that? I'm not tracking with you there. Can you please explain?
If there was no downward bias, any air generated at the surface would immediately diffuse, and there would be no pressure difference, like you do when you, like the ones you see when you're opening the stopcock on the pressures.
I heard the amount of ether. You said things rise due to buoyancy. I mean, man, you're throwing some terms out there. In your mind, can you articulate what causes the gradient? I don't have to. None of my presuppositions or any of my knowledge is in play here. I want to know from SC what you think causes the gradient. Can you answer,
can ask me 100 times. I answered the question already.
Get off
your high horse, bro. We are talking about Newtonian gravity versus Einsteinian gravity, and we're talking about your belief in
don't even do that.
Time, right? The ticking of a clock. This is what you've been convinced.
My God,
the ticking of a clock and the fabric of space put together.
We're not talking
gravity.
about that. Causes the gradient.
You can ask me 100 times. I answered the question already. Get off your high horse, bro. We are talking about Newtonian gravity versus Einsteinian gravity, and we're talking about your belief in
don't even do that.
Time, right? The ticking of a clock. This is what you've been convinced.
My God,
the ticking of a clock and the fabric of space put together.
We're not talking
gravity.
about that.
This is what your model. Shit. I don't care what you think.
It's so retarded. I don't care what you think about.
I don't care what you care. Then how's that? I don't care. I already answered your question.
Someone
I'm not going to answer again. Don't ask me again.
No, you said.
Don't ask me again.
Don't ask him again. He doesn't have an answer.
Well, the last time. I heard you say SE.
No, I'm not going to answer. You already answered.
You're interrupting me now. Stop it. SE.
Stop
Let me have my sentence. Thank you. So I asked you nicely. You go right back to this Einsteinian Newtonian conflict of theories and laws, whatever. I don't care about that. That all could be fake. In fact, it may not even be true. It could be wrong. I don't care. It's not my question. My question is, what do you think causes the pressure gradient? It's a simple question. I already
answered you. I'm not going to answer you again.
You didn't. You said because you put air in a container, there's a gradient.
I'm not going to play your game, bro.
Okay.
Believe what you want. Believe you're in a ball of gas in a vacuum. I don't care. Don't ask me again. You say
that, but you can't answer the question. You go back.
I already answered it 3 times.
You go, Essie, here being like a kid. Come on. You go back to the example of a container that has a gradient. So all containers of gases have gradients. That's not an answer. Can't you see that's just circular reasoning?
Too bad. If you don't like the answer, too bad. Go get a lollipop.
You haven't given me an answer yet. You have not given me an answer. Forget about what we think or believe. Forget about anything I learned in college or in physics or whatever. It's all out the window. I want to know what SE thinks causes this pressure gradient. And someone chimed in and said ether pressure. Now, I would love to hear the explanation of that, but you didn't say it. He said it. Can you give me an answer? Why?
I told you it's pressure.
Pressure.
And And that's it, bro. It's pressure. Gas is made at the
so
bottom.
pressure is caused by
This is
pressure.
the last time I'm going to answer this.
But you're not answering. You said pressure. Pressure causes
piss
pressure.
off, dude. Piss off.
No, pressure causes pressure. Does anyone in the audience agree with me that it's not the dumbest answer I've ever heard for any question ever given?
No, it's not the dumbest
I gave you a question.
Answer I've ever heard for any question ever given. No, that's a very hyperbolic.
That's not. I said, what causes this pressure gradient? He says the answer is, I've told you before, it's caused by pressure.
Okay, well, I don't, even if you think it's a bad answer, that's not the dumbest answer to any question ever given.
It is the ultimate. That's the floor.
Bro,
of
you've been here for how many years?
And dumbness. Yeah, because when you answer the question by circular reasoning, why is the door open? Because it's open. Why is this pressure? Because it's pressure. Why are you? Because I'm you. Because I'm me. I mean, that's the dumbest answer you can give for any question.
I told you buoyancy. I told you gas is made at
the bottom
and it rises to the top. I told you many times. You keep sea lining, bro.
No, I'm not. You
want to change. Stop interrupting me, man. You're very obnoxious, dude.
Oh,
I told you, you're doing this. You're sea lining because you want to get away from the fact that you can't have a ball of gas in a vacuum. This is what you try to get away from. You don't want to see the problem. You want to sea lion. That's what you're doing right now.
All right. So thank you for that, SE. I did get it. You gave me an answer. You said because it's due to buoyancy, but buoyancy does incorporate.
That's only part of the answer I gave.
Wait. Now you're I let you talk. Now you're interrupting me. So buoyancy is the weight of a volume that is being displaced, which was this comparative volume, density, weight is what gives things buoyancy. So it's got to be weight means gravity because gravity times mass is what weight is. So
okay, now which gravity?
I don't know how buoyancy is an answer.
This is what you
I don't know how.
Hold
on. I don't know how buoyancy is an answer unless you infer gravity because buoyancy incorporates gravity.
Perfect. I'm glad you went there. Now, which gravity are you talking about?
Any gravity.
You see?
Why is that funny?
This is why you sea lion, and you don't want to get to the root of your destruction.
You have no idea how honest I'm being right now, and I agree with you. It could be whatever gravity you want. It doesn't matter.
No, I'm asking you, which gravity are you referring to?
Either one. Doesn't matter.
No, pick. What do you mean either one? You can't have it both. One is mass attracting.
It doesn't matter what causes it. We know that the law of gravity does not change whether it's Einsteinian or Newtonian.
No, those are two completely different things.
Einsteinian just makes it more accurate, but the forces are still the same.
Those are two completely different things. I know you want to whitewash it. I know this is the part where your pseudo model falls apart. So I ask you again, which gravity are you referring to?
Either one. Doesn't matter.
See, that's why I don't even want to talk. You're just useless to talk to, bro. You don't want to.
I could be the biggest ignoramus in physics there is. All I know is that I know things fall down. I know that some kind of magical force pulls things down and accelerates them. Yeah, you jump off a building.
You're all about answers and specifics.
Hold on. I jump off a building and I'm weightless, and suddenly I start thinking, well, maybe that can't be right because why would I be weightless and I'm still accelerating? I should have a force on me yet I don't. So I'm torn between Einsteinian, whatever that is, and Newtonian, whatever that is, but I do know these things accelerate. So by virtue of these things, hold on, I'm almost done. By virtue of these things accelerating, that gives the reason for why we have hydrostatics, which causes this gradient. But you can't articulate that. You just throw up terms. Buoyancy.
No, I was very specific, and you're going back to that because you know what I'm going to ask you next, right? You don't want to distinguish. Don't interrupt me. You don't want to distinguish between Einsteinian or Newtonian because you know one has a force and one doesn't, and you know that's where you're going to get stuck in double speaking. That's why you refuse to answer the question.
Sure. Okay, I will answer it either way. So to answer you and to subvert your tactics there, if it's caused by bending and warping of space-time, I can deal with that. I can give you the terms that actually equate to F equals ma. Or
does it have a force? Does that one have a force?
No, the force in Einsteinian is a
what's keeping what's causing your gas from staying on Earth? What's causing it?
We have a pseudo force. So there is we have a pseudo force, which is basically it's reference frame. Hold on, it's a force that's reference frame dependent, and it has no origin. That is what a pseudo force is.
You know, when you say a force is reference frame dependent, that doesn't actually make any physical sense in reality, because when you say reference frame dependent, that means that, like, if you were to calculate it differently, there would actually be a different thing happening in reality. There's only one thing happening in reality.
That's not true. Because if I jump off of a building, and I can reference frame dependent, meaning the guy from the ground sees my acceleration, but yet I'm floating. I have no forces acting on me at all. It can be measured. You can drop your phone and see what the measurement is. It'll be 0. So it's not a contradiction. It's not anything other than
until you calculate how much energy those things have and start converting it to thermal energy, right?
You're going off the rails. You're going off the rails.
No, because hey, is thermal energy reference frame dependent?
No, of course not.
Of course not, right? So when we talk about how much energy something has in terms of kinetic energy, right? If we were to convert that kinetic energy to thermal energy and measure the thermal energy, that would not be reference frame dependent.
Velocity. No, you see, you're using terms you don't quite understand.
Kinetic energy is 1/2 mv squared.
Velocity is going to any kind of velocity is going to be dependent upon a reference frame. In the reference frame, right? Reference to an object or a reference to something else. It's all relative. The term is relative. You have to agree with that. So if I have, hold on.
Zanuck, you're going to run away. You're not going to answer my question.
Hold on a second. Don't get ahead of get over your skis there, tough guy. Hold on. So if you jump off a building and you have no feeling of any acceleration at all, you are weightless. Yet if I'm on the ground looking at you, you are accelerating. And due to Newtonian mechanics,
is there a force there? Is there a force pulling you down?
Yep.
No, it's a pseudo force. Has to be.
So if there's a force, if there's a force, it's not Newtonian, right?
It's reference frame dependent.
I mean, sorry, if there's a force, it's Newtonian, not Einsteinian, right?
Okay, so
gosh, hold on, bro, hold on. Let him answer that. This is the crucial question. This is what the gradient is all about. What they wanted me to answer the gradient.
Or it could be.
So which is it? Is it a force or is it not a force pulling you down?
It depends.
Yes, both. You hear that? You hear that double speak?
No, it's not double speak. It depends how you want to analyze it. You want to analyze it simply, or you want to analyze it not so simply.
There's no analyzing here. That's one or the other. You can't have it both.
Both models explain it. One model explains it more complexly than the other. They both explain the same thing.
Correct.
So you hear this? It's double speak dialetheism.
Not double speak. Okay. Not double speak. So not dialetheism. It's two things that say the same thing. One says it easily in language that people can understand. The other one is much more complex, and it takes like physicists to understand it. So according to Einstein, the space-time is bent by the Earth and by your body, and they both attract themselves to the sun.
So not a force there, not a force.
Well, not according to Einstein. According to Newton, there is though, which both of them.
So who's right? Who's right in this instance? Only one could be right.
No, they're both the same because again, Newton is a subset of Einstein. Newtonian physics are a subset of Einsteinian physics.
I believe I just destroyed your model without one question.
No, you did not destroy anything. You just for some reason are totally set on the Witzidism that Einstein superseded Newton when he just basically supplanted it, made it.
I don't know why you have Witzid in your brain, bro. I was saying this way before I heard the name Witzid. So if you got some sort of Witzid fantasy, go put a picture of him and go pray to him.
You use his words all the time. You use supersede. That is
those are my words.
Hold on a second, bro. Hold on a second. You're going to let Ruhiv off the hook. Hold on. Ruhiv, I need you to answer my question. Okay, so if I was to take a what's that plate called? One of those plates where when electrons like fly off and hit the plate, it converts their momentum into electrical energy, right? I could use that device, or we could just use a thought experiment, which is just easier. Either way, but
you're letting him off the hook, bro. Why are you letting him off?
Hold on, bro. If you take an object, because he says it's all reference frame dependent, I can test that. Energy is not reference frame dependent. There's only one reference frame in which the calculations are ever going to be valid. Okay, so if you were to take an object, so let's say it's like 1 Kelvin, right? It's really close to absolute zero. It's got basically no thermal energy. Okay. And we were to put it into, throw it, and now it's got a velocity. If we were to take that kinetic energy from that velocity, kinetic energy equals 1/2 mv squared, okay, and we were to convert that into thermal energy and then measure its temperature, how do you know which velocity is going to correctly predict the temperature you're going to end up with?
Wait a minute. Why are you giving it a temperature? Are you blindly just saying things?
If you convert the kinetic energy, there's based on the law of energy conservation, all energy has to be conserved. If we convert all the kinetic energy into thermal energy,
Correct.
okay, so it's not moving now, but it has got a temperature
relative
increase
to
based
what?
on
Hold on, relative to something else. So say it runs into a wall. Yes, that energy could be converted into a force that moves something, a counteracted force, as well as heat and light and other things, and noise. So yeah, all those things would be added together and would equal.
We're going to take
the kinetic. Hold on, if all you had was kinetic energy and it crashes into a wall, yes, heat would be released, and there would be noise. There would be deformation. There would be forces involved. So their point is not valid, and I know where you're going with it, but I think you're just a little misguided in your analogy or your description because it doesn't make a lot of sense. You're caught up with this. You're fixated on this thermal energy conversion of the kinetic energy.
Yeah. I said if I was to just click a magic button and convert all the kinetic energy into thermal energy, how would you know which reference frame? No, how would you know which reference frame would correctly predict the temperature?
You could measure it. In all reference frames, these objects will have a thermal.
I did not invoke a second object, by the way. I just said
no second object. You want to stop? You want to stop it and convert it? You have to stop it. How are you going to stop it? With a force? So you have flames out the back. There's your thermal energy.
I'm just clicking a magic button that makes it stop moving and immediately convert all that energy.
How does it do that? The magic button has to. You're breaking the first law of thermodynamics right there.
What do you mean? I'm converting it into? No, I'm not. I'm converting it.
How do you convert it? How do you magic? You said magic button. You can't stop it unless you have a conversion of this kinetic energy to thermal energy.
Can I say something real quick? Can I say something real quick?
Magic button.
Yes, sir. Go ahead, Professor. Hold on, guys.
So let me answer your question. Now that I have information, I'll answer your
Kenetic,
question.
go on mute.
The answer is zero speed. Your velocity would be zero.
Just want to.
Okay.
Go ahead, Professor.
Zero relative to what? It would become zero.
Whatever was measured before.
It's only valid in the lab frame, bro. That's the answer. That's the correct answer.
Let Parks talk about it because I've already given you the right answer and you're already accepting it. So go ahead.
No, I just want to make a quick point. You are making a distinction.
He's super fuzzy. I can't hear him.
Yeah, you're breaking up, bro.
Sorry. Can you hear me now?
You're kind of fuzzy.
I apologize. New setup. Hold on a second.
Try dropping and coming back in.
How about now?
That's good.
Okay. Sorry, it was Discord had me on the wrong input. So somebody is making the incorrect assertion that thermal energy is separate from kinetic energy. It is not. Thermal energy is by definition kinetic energy. So I don't know what you mean by converting something, all the kinetic energy into thermal energy.
I'm talking about the brute motion. It's brute motion, right?
That's what it is.
Yeah, but when we talk about KE, we don't talk about temperature. They're two unrelated things. I get the fact that that's the vibration, the molecular vibration. I understand it. You go solve any physics problem in any physics classroom, any university in the world, and they ask you about an object moving, having this much kinetic energy. They're not talking about thermal energy. They don't care what its temperature is. So that's not what we're talking about.
Actually, that is when you talk about when you're talking about thermodynamics.
You're a PhD, you know this. Don't be a liar, bro. Don't be disingenuous, please. We've all been to school. We know how this works. Stop trying to. I don't know who you're pretending for.
So, I'm not being disingenuous. I'm trying to correct you in that you seem to think that there is a difference between an object's thermal energy and there isn't. You cannot just get rid of a kinetic energy and turn it into something else that's called thermal energy. They don't care what its temperature is. So that's not what we're talking about. Actually, that is when you talk about thermodynamics. So when you're talking about thermodynamics. You're an object's thermal energy and its kinetic energy, and there isn't. You cannot just get rid of a kinetic energy and turn it into something else that's called thermal energy because they are effectively the same thing.
Hold on a second. Can I have two objects moving with the same exact velocity with different temperatures? Yes or no?
Yes.
So they're different. Thanks.
So they do not have. Okay. I see what you. The thermal energy. That is when you talk about when you're talking about thermodynamics.
You're a PhD, you know this. Don't be a liar, bro. Don't be disingenuous, please. We've all been to school. We know how this works. Stop trying to. I don't know who you're pretending for.
So, I'm not being disingenuous. I'm trying to correct you in that you seem to think that there is a difference between an object's thermal energy and its kinetic energy, and there isn't. You cannot just get rid of a kinetic energy and turn it into something else that's called thermal energy, because they are effectively the same thing.
Hold on a second. Can I have two objects moving with the same exact velocity with different temperatures? Yes or no?
Yes.
So they're different. Thanks.
So they do not have, okay, I see what you, yes.
So they're different. Thanks.
So they do not have, okay, I'm not being disingenuous. I'm trying to correct you in that you seem to think that there is a difference between an object's thermal energy and its kinetic energy, and there isn't. You cannot just get rid of a kinetic energy and turn it into something else that's called thermal energy, because they are effectively the same thing.
Hold on a second. Can I have two objects moving with the same exact velocity with different temperatures? Yes or no?
Yes.
So they're different. Thanks.
So they don't have.
Can I have two objects moving with the same exact velocity with different temperatures? Yes or no?
Yes.
So they're different. Thanks.
So they do not have, okay, I see what you,
physics problem in any physics classroom, any university in the world, and they ask you about an object moving, having this much kinetic energy, they're not talking about thermal energy. They don't care what its temperature is. So that's not what we're talking about.
Actually, that is, when you talk about the, when you're talking about thermodynamics.
You're a PhD, you know this. Don't be a liar, bro. Don't be disingenuous, please. We've all been to school. We know how this works. Stop trying to, I don't know who you're pretending for.
So, I'm not being disingenuous. I'm trying to correct you in that you seem to think that there is a difference between an object's thermal energy and its kinetic energy, and there isn't. You cannot just get rid of a kinetic energy and turn it into something else that's called thermal energy, because they are effectively the same thing.
Hold on a second. Can I have two objects moving with the same exact velocity with different temperatures? Yes or no?
Yes.
So they're different. Thanks.
So they do not have, okay, I see what you, the thermal energy has, is the sum of all of the kinetic energy within the particle, or within the object.
No, it's not. It's only the energy of the molecules vibrating.
That's the heat. The temperature is the average temperature, the average speed of the velocity of those molecules.
Of the molecules, not the object.
And the temperature will be the, hold on. You want to know about heat? You want to know about temperature? What are you talking about? I was speaking about the mass and a velocity relative to something else. Relative velocity.
And I'm talking about the macro scale motion, which we refer to as kinetic energy, or which we don't refer to as a kinetic energy. It has kinetic energy, rather. When we talk about that, and I say how much of that motion, right, is all that motion is going to be converted into temperature, right, into motion of the molecules rather than motion of the whole object.
You can't do that. I mean, what you're basically saying is, if something is moving at 55 miles an hour, you can then convert that into some kind of temperature?
Yeah, bro. This is my thought experiment. I hit a magic button. I convert all that. Hit all that energy, convert it into temperature, right? Which is
part of the that is part of the kinetic energy of the object. If
you already acknowledge you can have two objects at different temperatures moving with the same velocity.
Yes, and they have different thermal energies.
Yeah, but they have they have different thermal energies, but when they're going to have the same amount of kinetic energy.
Okay.
They're not going to. If one slams into a wall and the other slams into a wall, their temperature doesn't matter about how much energy is transferred.
Actually, it does.
All right, buddy.
So you're saying throwing a really hot object at a wall is not going to cause that wall to be hotter in the end?
I'm not talking about changing its temperature. I'm talking about transferring momentum.
That momentum is energy.
Right, kinetic energy.
Momentum is it's not. It is not the change in kinetic energy.
It's literally MV, bro. There's no temperature variable in momentum at all. It's MV.
Momentum is.
What is your PhD in again?
Let's not get insulting. I haven't insulted you, sir. I would appreciate it if you did not insult me as either. Jesus Christ is Lord. I am talking about the change in energy of a system, which includes the momentum.
Yeah, the rate of change of the rate of change of momentum is defined as a
It's
force.
such a simple question, bro.
Hold
I feel
on,
like
hold on. The rate of change of momentum is a force. Would you agree? The rate of change of that momentum is a force. So, rate of change of energy is change of energy. Whether it be kinetic or thermal energy, total energy is in a system, and it's going to
you
be
said
all
total
those divided
energy.
by-
Notice I said kinetic energy.
Kinetic energy is just the 1/2 mv squared. That's kinetic energy.
Right. Is there a temperature variable in that equation? No. Exactly. Thank you.
No.
So by definition,
Well, actually, of the object, there
it's
is
1/2 mv squared. Okay,
What
thank you. So if
the
you want to
atoms,
redefine
the
it and say it
atoms
has
that are
temperature,
moving.
you need to
Hold
show
on.
me an equation that would work with temperature
Well,
included.
that's not the total energy of the. So you're talking about the
I
object.
didn't say total energy, bro. I said I convert the kinetic energy to thermal energy. It could have all kinds of other energy. It could have electrical energy. It could have bond energy. We're not dealing with any of those. We're only dealing with kinetic and
Well,
thermal.
that has to do with the actual object's temperature and its total is heat. How much heat is in that object?
I know
How much
what
energy.
I know what temperature is.
What is temperature? Tell me the difference between temperature and heat.
Temperature is a measurement of the energy of the motion of the individual molecules.
What is heat then?
Are you talking about radiation, or are you talking
No,
about?
I'm talking about heat. They're two separate things.
Are you talking about the transfer of heat?
No, I'm talking about the heat. If some object has heat, what would be the unit of measure for that energy? If I had some object that had heat, what would be the unit of measure?
Well, heat is you can transfer heat. Heat is related to temperature, but we have conduction, convection, and radiation.
No, you're talking about how it moves. I'm talking about if you have an object and it has a certain. I'll give you the answer. It's measured in joules. And in fact, if you talk about second law of thermodynamics, you talk about entropy. It's Q over T, which is heat divided by temperature. So why would they do that? Why would they divide heat divided by temperature? There's a reason. You say you went to school, you studied all this stuff, but
you're talking about heat transfer. That's why heat means nothing unless you're talking about transfer,
you're
bro.
Saying that. You're saying that.
Bro.
I'm not saying that. I'm not saying that. You're saying that. I said if something has heat, that is how much thermal energy is in that object. The total kinetic energy that object possesses.
Okay. Heat is related to, I said heat is related to temperature. Yes, thermal energy. Where are you going with this?
Because you keep on, because you started. You got off on the wrong foot with Professor Parks and with me because you started talking about converting kinetic energy to heat, and he took it as meaning the entire system. And you're actually specifying just the object. Yes, if this object has a certain mass, 1/2 mv squared will tell you how much kinetic energy. And yes, if you want to bring it to a stop relative to some, hold on, if you want to bring it to a stop, there will be energy that will be required, and that could be heat, but it might not all be heat.
Yeah, I'm going to read you the definition.
Might be noise. It might be deformation of some object that's trying to slow it down. It also might be heat as well.
Yeah, I'm going to read you the definition. Heat is the transfer of thermal energy from one object or region to another due to a temperature difference. It is not contained within an object, but is the energy that moves between systems. So, as I said, it means nothing unless you're talking about transfer.
Well, you talked about transfer. You talked about this object stopping. Where would the heat come from? Or
how many times are you going to move the goalpost in this conversation?
I'm not you the one moving. You said that this object transfers all its kinetic energy into heat.
Kinetic energy into temperature, correct?
So that means it's had
into a temperature change.
Where did it come from? Remember, you already told about how you cannot,
buddy.
You cannot destroy or create energy.
Let me make it really simple.
Now you're making. You said you pushed a magic button and it stopped.
You're spiraling. Let me answer you.
I'm not spiraling. I'm trying to address your malformed idea and question.
Zanik, calm down, please. You were doing the same thing with me. Calm down.
No, I wasn't.
He always does it, bro. It's his MO. All right, Zanik, here you go.
You said I put the magic button.
Zanik,
I'm being very.
Let him get it. Zanik, can you go next, man? Come on.
Oh my gosh, stop being like that, Zanik. You have the
Never
impulse
me.
control of a
I
child.
don't care
I
who goes
literally
when.
know
You
elementary
go. Go
schoolers
ahead,
that
you
have
go.
better impulse control than you.
Look, you're the one that's talking over me. Go ahead. You go first. I'll go after
I'm
you.
talking. Now you're delusional. Okay. Anyways, I specifically said you have an object. You move it. It now has a velocity. Okay, this object is moving with some velocity. You were arguing that velocity is reference frame dependent, which means kinetic
No, I said
energy.
it's
What?
velocity is relative, not reference frame dependent. I said
Okay.
you don't you can't miss you can't get my shit wrong. You're regurgitating it incorrectly.
Zenik, is velocity reference frame dependent? Yes
I
or no?
said it's no. It can
No?
be, but the comment I made, well, you know,
That was
you
no the
said
whole
a
time.
force. A pseudo force is reference frame dependent. Get it straight. A pseudo
Right.
force is reference frame, not the
Right.
velocity.
That's what you said.
The velocity is relative. It's very
Okay.
important.
So if something
You
is
can't glaze over
relative,
these
is
things.
it
Let me
not
finish.
also reference frame dependent?
It can be.
Those two things are synonymous to each other. If a velocity is relative, it is necessarily reference frame dependent.
No.
It can't only be one.
All objects exist in all reference frames simultaneously.
Sure. When you go to measure the velocity, how do you measure it?
Relative to
With
something
respect to
else.
something. Okay, so then it's reference frame dependent.
No, it can be the same reference frame. You're not getting it. Unless it's accelerating.
Gosh.
Where you have hold on. You're missing. This is where you
Anyways,
need
I'm
to go
going
to
to answer
school
the
and
thing
listen.
though. You always do this. What is this
Because
phenomenon called where you jump to 70 different
physics,
points?
you don't.
Okay, buddy,
You're not
yeah.
getting it right.
Okay.
I can have a reference frame where things are relative to one another. It's in the same reference frame.
Zanik,
in fact,
stop being a child.
Let me finish the sentence. You might understand.
You interrupted me 50
You don't
times,
understand because you're not listening. You're just trying to talk over me. Let me finish the sentence, and then you can make a comment. What's so hard about that? So you can have
literally
velocity.
been trying to hog the mic.
No, you're not. No, I let you talk, and then I started.
You let me talk,
and you're
you
talking
didn't
over
let me
me.
do anything, bro. I was
okay.
talking.
Go ahead. Do it again. Go ahead. Your turn again. And get it wrong again. I'll interrupt you if you want, or I'll let you go. Go ahead. Your choice.
Okay, Zanik. Kinetic energy is 1/2 mv squared. Now, I said we take an object. Now we have this object and it's in some state of motion. It's moving with some velocity. Okay? You don't know what that velocity is, right? You don't know what it is. You'd have to go measure it first, but we haven't measured it yet. Okay? Now, we hit a magic. We hit a magic button, and it takes this object's total kinetic energy, not temperature, not heat, no other form of energy, just kinetic energy, the macro scale motion of the object, based on its velocity, 1/2 mv squared. And we hit this magic button, and it converts all of its kinetic energy, however much it is, we don't know, but all of it. It converts all of it directly into temperature. Okay, which is thermal energy. Converts into thermal energy. It now has a temperature change, so its temperature is now different than it was before. My question was, how do you know
the units of temperature?
How do you know
the unit of temperature?
Shut up, you infantile child. I was talking.
Thank you, Lord.
How do you know which reference frame to measure the velocity from, or with respect to what to measure the velocity from, to get the correct temperature prediction?
Temperature is measured in Kelvin, whereas energy is measured in joules. So therefore, temperature and energy are not the same thing. So your premise is faulty.
He won't stop talking to listen to that very simple explanation. He just kind of hit on a couple of points there. And I started with entropy because everyone starts talking about the second law. We talk about, what entropy is. It's equal to Q, heat, divided by T, temperature. Why is that important? We can talk about that later. You're talking about reference frames, and you should be talking about relative velocity. If we talked about your kinetic energy of your object, let's just break it down simplistically. You got an object, and it's going some speed, 1,000 feet per second or something. If you want to get the kinetic energy measurement, you could do that measurement, that calculation. You already articulated it. Now, if you take all that kinetic energy out and convert it to heat, Q, you wouldn't have to stop the object relative to where you're measuring it from.
Relative to where you're measuring? Why would it have to be relative to where you're measuring?
Because that's how velocity is measured. from its relative. Again,
so wait. No.
It's not
now
reference,
you're saying the temperature would be dependent on where you're measuring the object
no,
from.
if you let me finish, you might get it because I know where you're confused. I clearly know where you're confused on this, and if you just listen instead of try to talk, while I'm talking, you might understand it. So I'll give you two scenarios. You're in your house and you see a car drive by and it's going 100 miles an hour. Or we can do it. You want to calculate the kinetic energy? We can do it with the right units, but let's just say it's 100 miles an hour to be, just general here. We have a kinetic energy. If it runs into the brick wall, all that kinetic energy will be converted into, well, not all of it. A lot of it would be heat, deformation, and sound. Those three things are all energies that could be added up, and it will equal all the kinetic energy that it once possessed is now going to be gone, aside from the temperature of the object itself before it hit, which has also got to be in the equation because you got a total heat value. All right. Now you're saying it's reference frame dependent. Now I could be looking at it from somewhere else. In fact, I could be driving along with it, or I could stop at the same time it stopped, and that relative velocity would be zero the entire time. How would you say that relates to the object that was in a different reference frame? If it was accelerating or turning or measuring from a whole different position. How do you rectify that? That's what you're tackling right now. It's really simple. That energy to stop it relative to you is what we're looking at. If you want to convert all the energy relative to you, that would have a certain heat number value.
You mean the velocity relative to you?
The velocity, because that's how you get kinetic energy. 1/2 mv squared. You said it yourself. We stop that thing relative to us. There's this much kinetic energy in joules, a million joules. Let's say it's a million joules. That if it stopped, it's a million joules. Where'd the million joules go?
But why would it need to be? Noise? Why would it need to be relative to us, Zanuck? Why couldn't it be relative to anything in the universe?
Because that is how velocity is measured.
Yeah, but we're not talking about measuring velocity. We're talking about actual physical temperature change. So once again, you're making what you're. Hold on. Now I'm responding, Zanuck. What you're doing is you're taking this quantity, which is velocity, which has to be relative in your paradigm. And you're taking another quantity, temperature, which is a measure of the average kinetic energy of the molecules, right? Temperature is a measurement of energy.
Average.
Sure, because you have Brownian motion and every individual molecule moves differently.
Not the object's velocity. Not the object's velocity. That would be added to it.
Anyways, temperature is a measure of the kinetic energy of the molecules, whereas kinetic energy is the measurement of the energy of the macro scale object as it moves through space. Anyway, when we convert one to the other, you're saying that, well, we would have to change its velocity to be zero relative to us, and that's what would convert to the temperature. So by saying that, you are implicitly acknowledging that the conversion of the energy into temperature, therefore the temperature, would be reference frame dependent, because if you measured it from a different motion state of yourself, it would have a different velocity and therefore a different temperature. That's broken. There's only one actual temperature it's going to receive.
Do you know what a reference frame is? First of all, let's get there since we're going that direction.
Gosh, I'm not doing this with you,
What is a reference frame? What is a reference frame? What is a reference frame?
I'm not doing this retardation.
You're throwing temperature when you should be saying heat. You're saying reference frame when you should be talking relative.
I don't need to say heat.
So off the rails. It's hard to communicate with you because you're so off the rails with your terms.
Yeah, buddy.
So tell me what the reference frame is.
You really, truly don't believe I know what the word reference frame means.
I know what it means. It means it's where you observe motion from.
Okay.
It's a point coordinate system for which you view motion.
What would I have done if you hadn't told me that answer, Zanuck? Where would I be?
I don't know. A lot of people don't know what reference frames are. So we're not talking about reference frames here. Reference frame dependent is what makes a pseudoforce a pseudoforce. There is it's not a force. It's not a traditional proper force. It is reference frame dependent.
It's only a consequence of the frame which you observe it from.
You're being impulsive. You're not letting me finish the sentence. The reference frame is an environment for which you view motion. The kinetic energy is velocity is a major term, and that is relative to some point in space. In any reference frame, in all reference frames, there is a point that object exists. You're talking, then you talk about temperature when you should be talking about heat.
I'm not going in the circle with you again, Zanuck. We already cleared up what heat is, and it has to deal with transfer.
No, it doesn't have to do. It can.
I
That's not the
literally read the
definition.
definition to you. Do we need to go back
That's
into the
not.
replay?
So if I have an
Heat,
object,
heat is the transfer of thermal energy from one object to another.
it can be. It doesn't have to transfer. It can be. And it can be.
It is literally the definition. I just read it
because you Googled it. You didn't take physics, and you don't know what it means.
Yes, I did take physics.
No.
Okay,
You didn't.
you're literally living in a delusional world where you think you're psychic and you're projecting on the people, bro.
Okay, tell me what horsepower is.
It's a measurement of how much torque something. Not torque. Sorry.
Tell me what power is. Not horsepower. Just what is power? Define
what form
power.
of power? I mean, if we're
Just
talking about
power. You don't know.
I mean,
just tell me what power. Any kind of power.
Watts.
Mechanical
power. Yeah, it's energy over time, bro.
Rate of doing work. Be a better definition.
Yeah, I don't. Yeah,
So
energy. Saying that energy is the capacity to do work is a terrible definition.
No, that is a great definition.
No, it's a terrible definition. Yes. It's not an ontological definition.
Okay, what is entropy then?
Entropy is the tendency of a system to progress towards a less usable form of energy.
No, that's not the definition. Give us the physics definition of entropy. What is entropy?
It's the disorder. Look, dude, this is not a quiz.
No, it's not the disorder. It is the energy in a system that's not available to do useful work.
I literally just said that.
No, you didn't say that. You're talking about, you're confusing scattering and spreading out things.
Hold on a second, bro. No. Are you bipolar? I just really want to know, like, legitimately.
No,
do you take psychiatric
medication? Dude, it's hard to talk to someone who's got...
Do you take psychiatric medication?
You got a little Dunning-Kruger going on here.
Dude, yes,
you got a little bit of Dunning-Kruger.
Hold on. How many times have you acknowledged to us what's in your medicine cabinet before? And now you're going to say you don't take it, bro?
What are you talking about? There's nothing in my medicine. I don't have anything in there.
Okay. So what prescriptions do you have, bro?
0.
So then why do you project so hard onto people and try to act like you're like this godlike figure who knows everything about their lives?
Because you keep on using terms incorrectly.
Okay. So when you ask me what entropy is, and I said it's the and I said it's how over time the usable energy trends downwards. You said no, it's the reduction of the capacity to useful work.
That's the law. That's the character. The entropy is a measure of the energy unavailable to do useful work. That's a definition. What it does in a system or in a process is different than what entropy is. Yes, all that is part of the second law. Entropy is a principle of the second law.
Okay, cool. Glad we cleared that up. How is this? How does this matter in this meta discussion?
One way of measuring it is measuring heat divided by temperature. So joules divided by Kelvin.
You were wrong about the definition of heat, bro. That's what you're trying to get away from.
No, I'm not. You're saying it's just a
yes. Oh my gosh, you're the biggest scattergunner in here, dude.
Heat is the transfer of total thermal energy. That's a definition you read. But heat is the amount of thermal energy that an object possesses.
It's not possesses. Heat requires
the total energy. The total energy on all particles of a substance is heat. That is a definition. The units are joules. So you just because you went out and did a quick Google search, you think you know the answer, and you don't. I mean, it's partly right.
Heat is the form of energy transferred between objects due to a temperature difference.
You're doing a Google search.
Heat is the transfer of thermal energy from one object to another due to a temperature difference.
Okay. Now, okay, good, great. Thank you for that definition. You looked it up. I appreciate that. Now, would it also measure the total internal kinetic and potential energy of all particles in a substance?
Would it measure? It would have to be transferred.
No, it doesn't. You're dying on the hill of your quick Google search. No, the definition of heat. It measures.
Before I looked it up, I told you this in the conversation, bro. That's the first thing out of my mouth. I said, without transfer, heat means nothing.
No,
and then you argued with me, and then I looked it up to read the definition to you.
No, you want to convert.
We're in a recorded space. How are you going to deny what happened?
What happened?
No, you're misinterpreting what happened. You don't even remember what happened. You talked about this something that from a different reference frame.
So now you're trying to gaslight me, and you say that you're not.
I'm telling what you said. Okay. I'm reflecting what you said.
So you have no excuse. You have no excuse for gaslighting.
How can it have different temperatures? You even told Professor Parks about, can I have two objects going the same velocity with different temperatures? And you said yes, and he said he was looking at the total energy. At first, he didn't. At first, he didn't because
he literally said yes.
I know. He jumped in after. He jumped in after the fact. So let's go back to your original question.
Dude, you're literally spiraling and saying things that are just patently false. He literally said, yes, they are the same.
You're talking about something fairly complicated, and you think you know something that you don't, and it's very frustrating to communicate with you.
Oh my gosh, bro, this is wild.
That's why you're asking the question, because you don't know. We're trying to help you understand it. Okay, so to give me that object. That object is going down your street and crashes into a wall. We both agree that this kinetic energy converted into.
I didn't say anything about it. I said there's no second object.
I didn't say it. How do you stop it?
You just said it crashed into a wall.
Then you
I hit a magic. It's a thought experiment. I hit a magic button.
Then you put the brakes on and stopped. Either way,
said it's a thought experiment. I have a magic button that does the energy conversion process.
You can't do that. That breaks the first law of thermodynamics. Don't you understand? You can't push a button.
It doesn't break anything, bro. The energy is conserved. Energy is conserved.
Where did it go?
Into temperature.
What causes it to do that?
The magic button. Are you slow?
Brakes? No. See, you're. This is where people start taking things in physics as too literally. You just can't hit a magic button, and I'm converting it so it's totally okay. You just can't stop something.
Yeah,
and
the energy is conserved.
It has to be a process. There has to be something happening. The system has to have some.
Yeah, the energy
you have
is
to apply the
brakes,
or it has to run into something, or you got to fire a retro rocket. Something has to happen.
Yeah, all those things involve energy being transferred, right? So in my illustration, when I hit the button casts a magic spell that causes all the macro scale kinetic energy to convert and transfer into the molecule's vibration.
Great.
It's conserved.
Fine. We'll talk about a car because then it's not magic anymore. The brakes all take all the heat and the
no, because it's fundamentally a different scenario.
Why?
You're trying to bring in a wall. I don't need a wall.
No wall.
Then you're going to measure relative to the wall.
Brakes.
And say the
I said brakes. The brakes are on the tires. It's all part of that same mass.
So it's going to be the velocity relative to the ground then.
Hey, want to learn something? Stop talking. You got the car with the brakes. No other
Dude,
wall.
You're not going to talk to me like a child when you're literally off the rails this entire time.
Stop talking over me. You got a car, it's got brakes, all that mass is added up, it stops. Don't need a magic button, just push the brakes. And yes, will some of the stuff go up in noise? Will some of it go up in light? Yes, but let's just say those brakes are so efficient that all that energy went up in heat. So yes, you contain all that heat in that object when it stopped. Magic button solved. Okay, it's the same thing.
So what velocity did you use to predict how much heat it produced?
0 when it stopped, and the velocity it started with, which was 100 miles an hour.
With respect to what?
To you, to the ground.
To the ground. On. Okay, so the lab frame. Thank you.
Yes, the lab frame.
Thanks for playing.
No, go ahead. What do you want to know now?
Thanks for playing. I said the lab frame is the only valid frame in which the prediction will work. So you acknowledge that by invoking an experiment.
You could be on a moving sidewalk. You could be a jet in the air. The air is moving, and you're on the ground. The lab frame, but the jet is in the air where it stops relative to all the molecules around it. And you are also in a balloon. So relative to you in the balloon moving with the air, you can get a relative velocity there. Not a problem. So you're just now you're getting. I can tell you're stopping because you're thinking now. If you're in a moving air mass, hold on. You're in a moving air mass and you're moving across the country. Let's say you're in the jet streams, 200 miles an hour, and you're going 1,000 miles an hour in this airplane. You stop relative to the balloon. Now you're hovering with the balloon. Stop. That energy went up in heat, but it's not the same number as someone looking at you from the ground because you're going 200 miles an hour past them.
Here's the problem, Zanuck.
There's more kinetic energy. Hold on. There's more kinetic energy that's still there.
You're just going to monologue forever.
I'm almost done.
Next time you interrupt.
This is why I go crazy because you just don't stop talking. So,
oh my gosh, you're literally projecting yourself onto me.
Jesus as Lord, please. So you have this guy on the ground that looks at you guys go by. You're both stopped relative to each other. You've done your calculations for how much heat's gone up, but relative to me, you still could stop even more. And there's still more kinetic energy available. So the kinetic energy you got rid of based on the balloon is different than the kinetic energy you could actually convert into heat from the guy on the ground. That should really clear up your problem. If it doesn't,
it doesn't clear up the problem, Zanuck.
All right,
because I said in the beginning, you still haven't answered my question. All you want to do is say, instead of using the thought experiment you made up, let me create a different one and answer the one I made up and not address yours at all because I can't answer it. That's all you ever do, bro. I said all the kinetic energy the object possesses will be
relative to what?
transferred. It's not relative. Energy is not relative.
It is. Speed,
No,
velocity is
not.
relative to something. Speed is relative. One of the first things you learn in physics.
Okay, so when you talk about conservation of energy, right, is mass reference frame dependent?
No.
Okay, so then if I say I take an object of a certain mass and I convert it all into kinetic energy with
Relative
respect
to what?
Oh, no. Until all the mass is gone. See, I don't have to invoke any
All the
frame.
mass is gone. Where's mass going?
I take 1 kilogram of mass and convert it into kinetic energy.
That means it's got to be moving relative to something.
Okay, Zanuck, great. So, with respect to what is
the guy in the
going to
balloon or
predict
the guy on the ground?
velocity?
What do you pick?
Okay, when you do mass energy conversion, if you were to convert it to kinetic energy, no, you'd stop interrupting me.
Energy
Shut
conversion.
up, child. You're interrupting me. Stop being a hypocrite.
Completely different equation. Now we're talking about mass energy conversion, like E equals mc squared. Completely different conversation. Now I know why you're confused.
I'm just going to do this. Please stop.
I get it now.
I literally let you talk for 2 minutes, and you can't give me 10 seconds until you freak out like an impulsive child. You're a hypocrite, bro.
You don't need to call names. Go ahead. I just found your error, but go ahead. You can try to clarify. Go ahead.
Yeah, so I convert the 1 kilogram of mass into kinetic energy. And you say, with respect to what? And I said, you have to pick with respect to what will predict the correct amount of velocity. So if I am on the Earth, right? We're all on the Earth, and I have this rock that is sitting on this bench, and it's got a mass, right? So I'm going to convert this 1 kilogram rock, right? I'm going to take all that mass, put it down to, I don't know, whatever's left, I guess 1 particle, because you have to measure something moving, right? Convert that 1.00001 kilograms, take away 1 kilogram. Now how fast is that particle moving? Saying with respect to what does not make any sense in this scenario.
No, whatever you said made 0 sense. You might want to rephrase it.
I'm not done talking, Zanuck. I'm not done talking, Zanuck. You're interrupting again.
No, you stopped.
You're being a hypocrite. I'm not finished.
No, I'm not being. You stopped.
Dude, I literally took a breath in the middle of a sentence, and you tried to interject and talk as fast as you could.
Thought. It was incorrect.
All right. So when you convert this kilogram into kinetic energy, how much velocity will the remaining particle have? You're going to say with respect to what? And I say, okay, well, you're going to have to pick which frame is going to correctly predict how much it will have. Because here's the problem, Zanuck. I'm extending this argument from earlier into an extra step. I'm going to say we convert the mass into kinetic energy, and then we convert the kinetic energy into thermal energy. So you have to tell me in what frame you measure the velocity that will give a correct temperature prediction. It's only the lab frame. So we're taking two variables that are not reference frame dependent, that are not relative at all, mass and temperature. We've got one variable in the middle that you claim is only relative, which is velocity. But that would mean that if we start with mass, then we go to kinetic energy, then we go to temperature. If you say velocity is relative, then I can make the final answer anything I want. You have to use the lab frame. It's the only one that'll work.
That's not true at all.
Okay, that's a tautology.
I let you talk, and you went a lot of different directions, and you made a lot of errors through there that I noticed. But I'm not going to criticize everything. I'm just going to say, look, the velocity term in the kinetic energy is relative. And I like to use an example with you push the magic button or whatever, that energy cannot be created nor destroyed. In your case, destroyed. So it goes out, and you're saying you're forcing it to go up strictly in heat. If I stop some object in the sky relative to the surface of the Earth, it'll be one value. If I stop it with reference to something that's floating in the air that's already moving, there'll be another number. And the heat that's going to be generated in that object will be comporting with the amount of kinetic energy that you've changed relative to the other object, relative to the observer. For example, if you, like I said, you give the jet stream, you're stopping with someone else that's on the jet stream. You got a balloon in the jet stream and you're on an airplane in the jet stream. You're going to stop relative to the jet. You're going to be zero velocity with respect to the balloon. And all that heat that it took to slow down and go from 1,000 miles an hour to 200 miles an hour, jet stream speed, that heat will be transferred into the object itself. Because you had to use that energy to stop it. So the energy was converted directly into heat because you made the terms in the hypothetical situation. But if you wanted to stop again, because now we have zero speed, zero velocity, and this much kinetic energy that turned into heat, but relative to the ground, you're still going 200 miles an hour. So we got to stop again, take another 200 miles out of it, times your 1/2 mv squared, times the mass and the velocity, 1/2 the velocity. You will now have another temperature rise relative to the guy on the ground. And if you want to compare it to some other star or planet in the sun, then you can either gain or lose kinetic energy based on where you are with respect to that other object. See,
So
you just have
I might be psychic,
you're
bro.
just caught up with this. Let me close by saying you're caught up with this reference frame thing. Reference frames are just an environments for which you view motion. That's it. And a pseudo force is reference frame. A pseudo force is reference frame dependent. For example, like centrifugal force. There's no force acting on me getting thrown out my door as I'm going around a racetrack taking a left turn. I hit the door. That's a pseudo force. The door acting on me is a real force because it's a door and it's not going anywhere. But if it wasn't for the fact that you're turning the car, I wouldn't be hitting the door. But how much more I turn it, the more force I generate, which is a pseudo force. It just means it has no origin and it is reference frame dependent, which it is. So that's like like the first quarter of physics right there in a nutshell. Talking about velocities and momentum and energy and heat and temperature. I mean, we're going over all of it like in 5 minutes. So it's going to be
finished with your monologue, bro. You said 5 seconds or whatever.
Well, I mean, I figure I just take the liberty to kind of just say, hey, I appreciate the topic, and we're just kind of spitballing some stuff here. But you're hung up with this fact that the mass is not reference frame dependent, nor is the temperature, which is true. But the energy that you converted into heat is going to be relative to something else because velocity is relative to something else. And with that, I'll stop and let you come in.
Yeah, dude, I think I might be psychic, bro. I literally predicted at the beginning of this. I said, Zanik, you're not going to answer my question. And you went and just like invented 3 different scenarios that had nothing to actually do with my scenario because they're fundamentally different. And then acted as if you'd answered my question when you didn't.
No,
hold on. If I take a 2 kilogram block and I convert 1 kilogram of that block's mass into kinetic energy so that it's still just a 1 kilogram block after I do that, and now it's moving.
What? Where'd the other kilogram
go? And now
it's
mass energy conversion, right?
No.
I hit my magic button. Stop, Zanik. I'm answering your question. I hit my magic button. We use the Einsteinian relation where mass and energy are equivalent to one another. They're one and the same thing that can be converted back and forth. I hit a button.
MC squared.
I hit a button and I convert this 2 kilogram block. I take 1 kilogram of its mass and convert it into kinetic energy so that this 1 kilogram block is now moving. Okay. So you can convert 1 kilogram of its mass into kinetic energy. Now it has a velocity. Then I hit the button again and convert that kinetic energy into a temperature change.
Absolutely not. You're off the rails.
You have to use the lab frame in order to be able to answer my question of what would its velocity be that will correctly predict the temperature change.
Can I stop you for a second because you're really going off the rails and you're compounding your error by continuing this conversation. We never talked about mass energy conversion as in from mass to energy. You were talking about kinetic energy to temperature. Now you're talking about.
Bro,
hold on. Let me just finish my statement. Hold on.
No.
If you want to take 1 kilo,
you've said like 7 times as many
words.
No.
This is important because this is the crux of your problem here. So you're saying if you have a 2K block, you take 1 key and convert it to energy. What is the temperature going to be? I mean, we're talking about a nuclear explosion. We're talking about Hiroshima bomb.
We're talking about a magic button. Do you see how you failed to understand even the most fundamental basic points of my thought experiment?
If you
literally just completely change it.
Nuts.
You straw man
you don't know
everything
what you're
that you
talking
address.
about. You
You
don't
straw
know
man.
what you're talking about. You're
How
talking
do
about
I?
kinetic
It's
energy, and now it's
my
mass energy
thought
conversion, and you're talking
experiment.
about
It is a
velocities and lab frames. You're
fictional
all over the map. You
thought
know what? I'm out.
experiment,
I'm out.
Danny.
You're
It is
doing this on
fictional.
purpose.
It's
Oh,
fictional.
good. He's out.
How are you going to tell me I don't know what I'm talking about when it's literally a fictional scenario, bro? You're like telling me, no, you can't do that. How are you going to tell me I can't have a magic button? It's my magic button. It's not
You're
your
using
magic
the
button.
wrong units of measure. You're using the wrong everything. First, it was kinetic
Temperature
energy.
is a measurement of energy.
No, it's a molecular and atomic energy is completely different. Mass energy conversion. E equals mc
Okay,
squared. Hold on.
buddy.
E equals mc squared. It's not just E equals m. It's E equals mc squared. That equation is for a reason, and you're just glassing over that and trying to think that E equals mc squared is the same thing as saying that E equals kinetic energy, which is and mass equals mc squared. But mass does not equal mc squared. Why is the
That's
mc
actually
squared there?
the short form of it. You'd have to use the long form in order for it to
No,
work.
that's not how it works.
What?
Your mass.
There's not a long form of E
You're
equals MC
frustrating me now
squared.
because now you're so out there. I have no idea what you're even asking, and I don't think anybody else does either. So have fun with that. Thank you. I mean, I didn't mean to get upset and talk over you when I did, but it was very confusing what you're asking, even with your magic button. I was trying to give you a kind of a layman's
It's actually
description, but
E equals
it was
MC
all
squared squared
wrong
plus
because
PC squared.
you can't get a velocity equivalence to E equals mc squared. Okay, just so you know.
You can get a velocity equivalence to E squared equals MC squared squared plus PC squared.
Yes, you can get a E equals mc squared and then attach a kinetic energy value to that, whatever's left. And it will
This
be
right
some
there.
huge, yes, you're going to get some huge, some kind, Hiroshima bomb converted to kinetic energy. What is the mass? 1 kilogram. Okay, give me the billions of joules that are released in hum, and then give me a velocity. It'll be faster than light speed. So it won't work out for that either. And then you just put E squared equals mc squared squared plus PC squared. Yes, exactly. You're not going to get a value. You can't take 1 kilogram of the 2 kilogram and equate it to a velocity because it'll be faster than the speed of light.
What? How would it be faster than the
You
speed
heard
of
me.
light?
It doesn't work that way. You cannot convert it to kinetic energy.
You can't convert. So you hold on. Wait. You can't convert mass into energy?
You can, but you cannot convert mass into energy and then equate it to a velocity.
Like, who said I was equating it to the velocity? There's a comporting
You
velocity.
want to know what the velocity would be?
Yeah, there's a relation there. You can solve for v. That p value is mv.
At some point, the velocity will have to be.
Hold on, bro. I'm still talking. You change the p to mv in that equation. I just pasted that image. I just pasted. You change that
You
p to
cannot
mv.
get anything fast enough to be.
So then you have a v, and you know what the m is, right? So what you do, right, is you start with this object at rest. You have energy 1, which would be you'd make p 0 because the v is 0, so it would just be E equals mc squared. And then you'd have E2, which would be m would be half of m1, m2 would be half of m1. And then you solve it to where the v, whatever v you plug in, will make E2 equal to E1. And that's how you get your v. But that v would be with respect to the lab frame. That's the only. You have a v. You have an absolute v. Like that's the v you get. But then you have to ask the question: this v is relative to what? Well, the v is relative to the lab frame. That's the only thing that would work. Because every object has a rest mass, and E equals mc squared deals with the rest mass of an object.
Did everybody stop talking?
I want to see some more slides and videos of cells. It's mind-boggling to think that our body, our human body, is made up of little critters. Like literally, lots of little critters.
What if the cells are actually just like little tiny balls of water undergoing like a certain frequency and vibrating so they look like they do?
It's not possible because under a microscope they literally look like little parasitic entities.
What's in between the entities?
You mean like the protein or something?
Yeah, like when you're looking under a microscope and you see little parasites floating around.
Kind of like
It,
what it looks like they're swimming in something, right? Inside some type of a solution or a medium.
well, what would be like in our body?
You know, like per square, I don't know what measurement would be the best one to use. Per square millimeter, how many of those little critters are in there, anywhere in your body at any given time? Like, are we talking hundreds or thousands? Probably have to ask Taylor that. How many of those little moving entities are in our 1 square millimeter, 1 cubic millimeter of our body? Like, what's the ratio? What's the ratio of like the medium that they're in, be it protein or whatever, and little entities like what we see in the slides? I guess she's busy.
What scientific experiment do you think there is that shows that prion diseases disease or like that prion specifically cause death in the same way that, like, you know, with viruses you have cytopathic effect experiments. Well, does anyone know like how they know that prions kill things or are the cause of death?
What's a prion?
They're what they're claimed to be is misfolded proteins that cause people to die. Like, it causes the death of neurons. And it's like, I forget, you know, like mad cow disease. I'm pretty sure that is prion disease. I could be wrong there, but yeah, there's a bunch of different types of prion diseases, and they like invariably cause death usually. I'm like in the middle of like a text conversation about prions, and I don't know much about them, but he brought them up when we were discussing virology, and how I said there's not really any experiments that prove that viruses cause cell death, or especially in death of humans.
So is it like something eating away at the nervous system?
Yeah, I couldn't articulate. I mean, you would just have to Google. I don't know. I can't articulate the exact mechanism by which they claim that prions kill the neurons, but something like that. And then we got into discussion about cancer, and he said to think of prions just like cancer, and I'm like sitting there thinking, like, you know, I don't really understand how cancer kills people aside from the fact that it's spreading. And I mean, that is the main mechanism, and it's just like, you know, it spreads to an organ, but how does it kill the organ or whatnot? You know, I don't understand that necessarily. All right, so the explanation for how prions kill is your brain normally has prions that are crucial for cell function, but we don't understand exactly what they do. Um, the misfolding, infectious prions come into contact with a normal protein and trigger it to misfold in the same bad shape. So it's a protein virus. Okay, it's kind of weird. This creates a domino effect as each new misfolded protein then converts another, leading to a rapid buildup. All right, so trees, yeah, that's pretty self-explanatory. These misfolded proteins aggregate, forming toxic clumps and plaques that physically damage and kill neurons. The accumulation of these protein deposits create tiny holes in the brain, giving it a sponge-like appearance, hence the name transmissible spongiform encephalopathies. I don't know how to say that. And then it just kills the brain. All right, so where do these come from? Now? All right, and then so the prions are caused by random errors, genetic mutations, or exposure to existing prions. I mean, you might as well just say it's a toxin.
Is everybody quiet or what's going on?
I can keep talking about prions if you want.
Well, this has been an interesting evening. We started off with gas pressure without a container next to a vacuum. Then we had Zanik sea-lining me about how does a pressure gradient work. He wanted me desperately to say gravity. Then when we got to gravity, they were double speaking that Newtonian and Einsteinian is the same thing. And now complete quiet? What's going on? Hey, let me ask you guys something since it's quiet. I was listening to some people talk today and they were saying, what's it going to take for the American people to see what's going on around the world, blah, blah, blah. And one guy said, well, they're just not interested in what's going on beyond their borders. And let me ask you guys, in your regular lives off the internet, does anybody talk about what's going on in Ukraine?
These people are real. You're all AI. Stop acting like a human. Talking about in your everyday life.
Well, you know what I mean, off the internet, off the discords, like in your regular, your regular dealings with people, the scuttlebutt, as they say. Does anybody talk about what's happening outside of the, outside world?
Yeah. I mean, people talk about it all the time. I mean, you're in Canada. That's pretty much America. It's probably the same.
Well, I don't see people talking about what's going on in Ukraine or in Israel. In my dealings with people, they talk about the weather a lot here in Canada. I'll tell you that. You're going to tell me you heard conversations about Ukraine or about the war or about China or about Venezuela. You heard conversations like that in the regular world?
I mean, with friends and group chats. In real life, no.
That's what I'm thinking. Yeah.
I mean, it's like between people I know, but people have stopped kind of bringing up anything political. In everyday life, I think. At least the people I'm around.
Don't you find that weird? Nobody talks about like real things. They talk about sports, they talk about weather, but they don't talk about like what's beyond the borders, what's going on in other, like in the
Because
world, for example.
it's controversial. They don't want to cause like a fight.
Right.
I mean, that's why I don't talk about things all the time. It's like I know that it will cause a fight, so what's the point? So, especially if I know I'm not going to get anywhere in the conversation. Why would I bring it up?
I hear that. Yeah, makes sense. So when they were asking them, well, what's going to happen in the world? And the guy says, look, most Americans don't care. He says, look, the only way that people are going to start caring is if they can't put gas in their car, they can't put food on the table, then people are going to start to ask questions. Beyond that, no one's going to ask anything. That's why our governments are free to do and cause war and make havoc around the world. And yeah, I guess that is the correct answer.
Yeah, I mean, if you keep the people from starving, they never revolt. That's rule number one.
Like the French Revolution, right? People started revolting only when they couldn't afford to buy bread, right? Let them eat cake. Remember that saying, let them eat cake? So yeah, I guess that's what we are. That's what human nature is. We only care about ourselves and I guess our families, and we just tend to block everything out.
but people know who scored the latest touchdown or how many home runs a certain person has, and yeah.
What two countries are you talking about, SE?
I was talking about like Canadians and Americans.
No, about the war or something. What's going on, like beyond the borders? You were talking about like some stuff going on. Are you talking about the Israel situation?
Well, there's that. There's America's fixing to go to war with Venezuela. They're talking about attacking Iran. There's the conflict in Ukraine. There's the China Taiwan thing. There's so many things going on around the world, and we're the cause of it. Like, we're literally the cause of it. We, meaning mostly America, you know? And it seems like nobody talks about it. Like, it's not in the public conversation. Whereas football, hockey, baseball, you know, what the Kardashians are doing, you know, what Snoop Dogg is up to. Because I was listening to some commentators and they were saying, what's it going to take? What's it going to take for, um, you know, for people to, or what's it going to take for us not to go to war and change? And he goes, look, the American public, it's all about the American public, and they really don't think about this stuff. And the only time that they're going to start thinking about this stuff and we have changes when, like, he brought up the French Revolution. And it's funny because I talk about that as well. And he goes, look, the French, there was all kinds of problems going on around the world. They were doing wars and everything, but the people didn't care. But when they started not being able to put food or buy bread, that's when all hell broke loose. And, you know, the French Revolution, right? The guillotine and all that stuff.
Yeah, but like America's one of the countries in the world that has the lowest petrol prices, right? In the entire world.
Yep. Yep.
So if that's the case, and the whole world is using the American currency, and like, when's the last time that anybody, like, besides 9/11, like an actual kinetic war, when's the last time that anyone ever invaded America? In most people's history, like idea of history, it's never happened kind of in their lifetime, right? That they actually invaded America. So I think most people are quite confident that whatever the American government's doing around the world can't be that bad because no one's ever invaded them, you know? So I think they're just peacefully like satisfied with the status quo, and they've got more important things to worry about. That's why most Americans have two jobs, right?
Well, yeah, that's part of the thing. Now, most Americans do have two jobs, so it's starting to hit home. But I get your point exactly.
It's like those things you were talking about, like the sports and you know the those are just part of the entertainment. It's kind of like alcohol. It's kind of like brain numbing, like necessities, because life is so mundane in the material world. And when you have anxiety, which is run rife, and nearly every like 75% of all university students, or I think it's 75% of the entire population in the United States are on antidepressants of some description. So I think that's just telling to like what's the word? Cognitive dissonance. I think that's what it comes down to.
Interesting. So are
It's
you
like
saying
a
they're
mental
aware?
block.
Sorry?
It's like a mental block that people put there as a safeguard so that they don't like let it get the better of them, like in the way of anxiety. So I think that most people don't want to go there. It's just like a taboo sort of a subject in most cases, and people have you know, concerns about their mental health is more important than thinking about the worries of the world.
Right. So everybody's like taking care of themselves and their immediate surroundings type deal.
And they kind of have to. If you look at the statistics, the amount of people that are on drugs for depression, it's outstanding. And young people as well, like people at schools, there's so much going on with the physiology of like the younger generation. Girls want to be boys, boys want to be girls, and it's being pushed from the upper echelons. And there's just entertainment bombardment, TikTok, Facebook. You've got like social media coming out the wazoo. It's just there's too much going on. It's just busy, and people, the last thing people really need is more blue light and more stuff like to take up their energy, and I think people are just worn down to the point whereas, everyone's going to have autoimmune disease soon because their bodies are just not going to cope with the amount of information that's out there. And now we've got AI putting out all this fake stuff. People are finding it hard to distinguish what's real and what's not.
That's a good point. The AI, yeah. I've been running into a lot of it lately. Like figures I know that I listen to, and people are just making AI of them and just making them say whatever they want. Yeah, it's yeah, that's pretty bad. I agree. That AI stuff, man, that's something.
Bob Marley said it like in one line, and it's true. People are enslaved in the mind. It's all a mind fuck, excuse the pun, but that's true. That's what it's all about. It's mental slavery. That's like that's the most powerful form of slavery.
Yeah, I agree. Taking over somebody's mind. Yeah.
If everybody just stopped using anything to do with a screen for a whole week, if we had a worldwide no screen week, so no Tesla, no mobile phone, no computer, no yet laptop, no iPad, none of that, no TV. Imagine if everybody just stopped using a screen okay, we have to let the people do their finances, right? So I guess you still have to let the stock market do its thing, and people that absolutely like critical to use the screen. Yeah, fair enough. But just imagine if like the majority of people were able to go without a screen, like, okay, you're still allowed to use like some form of communication, but take away the blue light screen for a week and see what happens.
What do you think would happen?
people will be in the parks, having picnics, observing nature, looking at like grounding themselves. Because people will feel like anxious, people are addicted to the screen, man. Some people, they can't go without like 5 seconds without having to, they're not even expecting an email, not expecting a message, but they're just constantly checking their phone to make sure that it's still there in their hand. It's just like, impulsive addiction. And I think they've got the whole world addicted to, I don't know the way to describe like the effect it has on your neurological system, but it's affecting so many things like people's memory, a short attention span. It's like the blue light is affecting your mitochondria, your brain and gut connection. It's all like, it's giving people autoimmune diseases because they're just not getting, like, it's the opposite to good light therapy, right?
Can't disagree with that. Yeah.
You must have
People
seen
are
some of
walking
those
around
shows
and
where
their
they,
heads.
yeah, just walking, talking, like, you must have seen those shows where those reality shows where the parents will get their kids to, like, they lock up their mobile phones in a box because they really can't control themselves. So they actually have to physically put the phone in a box with a code on it or a lock, a phone box. It's become such a serious issue.
Yeah, definitely. Like I was gonna say, you see people walking around, crossing the street with their heads down, almost getting hit by cars because they're literally in the phone as they're walking. Yeah.
I've seen people riding their bikes and trying to do like shit on their phones, text messaging or whatever on their phones, scrolling through, and they stop at the lights and instead of looking at the traffic, waiting for the lights, they're just looking at their phone. Crazy.
I know
Clown
children
world.
who can't go to sleep without a screen.
They
I,
go to sleep with their phones.
Yeah, literally the parents put a tablet in front of both of the children during bedtime. It's like, and you can see the child just go, their brain just numbs. But that's the only way they would fall asleep. They're addicted.
yeah, we're living in a clown world now. Like I deal in secondhand machinery and I advertise stuff on Facebook, and I will advertise, and people would message me. I put my phone number on it. Ring me. I'll talk. Talk to you. No one rings you. They'll message me, but they will not ring. Or about 1 out of 5 will actually ring up and get information on the stuff.
Yeah, that's another thing I find with customers. I try to
Yeah.
call them, no one picks
No.
up the phone. But if I
No.
text them, they'll get back to me or email. Like, what the
I,
hell, man? You don't want to actually talk to a person? What's
no.
going on?
It is fucking weird. I I have like probably 200 ads on Facebook, mainly machinery and equipment, but they will not ring me. I'll send them my phone number, and then they'll text me.
Yeah, yeah, yeah.
Yeah,
Same here.
it is like stupid. My son puts stuff on Facebook too. He says he tells them, he says, listen, if you want to come out, I'll leave it out the front door, right? Just put the money under the mat, and they'll come out, pick it up, and put the money under the mat, but they won't interact with you.
It's weird, man. Yeah, it's definitely weird.
No shit. I just got a message on my phone like a couple of days ago. This bloke, he sent me a message. He goes like, "Oh, I'm someone from Facebook, and I'll give you $50 for the thing. Can I come and pick it up tomorrow? Didn't give me his name. Didn't even say what he was looking at. And I've got 200 items on Facebook, and I'm going like, what? I go, you got to be stupid, person. It is literally a clown world now.
So everyone's in the matrix. They have succeeded. Wow.
Oh, yeah.
I had someone buy my truck 3 times. Like I was selling a truck. It's actually still for sale. And 3 separate people online have bought my truck. They paid like they bought it like through auction, and 3 times in a row. These people never contacted and never came and picked up the truck, never paid for it. They just bought it and then just left it.
Yeah.
How could they buy it
That's
without
in the span
paying?
of only 1 month. 1 month. Strange. I don't know if that's relative, but I think it is got something to do with the online sales mentality.
Yep. We're in deep shit. I feel really sorry for the next generation. They are in.
Well, the next generation is going to be neuron plugins.
Well, I don't know about that, but they're already plugged into their phone, and you see it all the time. They're walking around just with their head in the phone all the time, playing games, messaging people with just bullshit. Like, I mean, who wants to see what you eat? I mean, I don't know. People don't want to know about. People don't want to know about anything. They just all they're interested in is themselves now. They go to the gym. They get tattoos, piercings. I go like, honestly, I cannot stand tattoos on a woman. I mean, it just looks dirty to me. Like you feel like just a lot of scrub it off. But it's just clown world. Total. Everybody's living in, I don't know, their own little world, and it's all fake. They don't know how to interact with people. I mean, I talk to usually a lot of people every week, but most of them don't want to know about anything that's going on. Don't want to know about what's causing the problems. Some people fall onto it, and we're on the you're on the same page, but most people are in just a different library. Like they're not even worried about it. And then when it happens, it's they're gonna get a big shock. I mean, I live in Perth, and the real estate market over here is ridiculous. It is. I don't even know how people can afford to buy a house. I really don't know. You're talking average price now up around 600,000, 700,000. Is that, and that's just like a unit. A normal, like a reasonable size house, you're talking 1.2 million.
Yeah, it's the same thing in not so much in Montreal, in Toronto especially, or Vancouver. Forget about it. You ain't buying a house. Forget about it.
Wasn't Trump talking about making it so that they're going to have 50-year mortgages now instead of 30?
Yeah, I heard that talk as well. Yeah.
You're in a debt trap, and that's the problem. And there's only one solution to it, and that is you got to give the land away. Because the land over like here is nearly worth more. It's probably could be even double the price of a house just for the land. Where I live, my father bought it in 1965 years ago for £54, right? Quarter-acre block. That same block of land, my brother and my sister still live on it, and so does Mum. It's got 3 houses on it, and just the land would be worth 1.5 million without the houses. From £54, which is, say, $200.
It's crazy here in New Zealand, in Auckland.
Yeah.
Land is so expensive, but they don't make use of it. They're building all these new housing developments with like 2-story bungalows. When the land is so expensive, the logical thing would be to build 10-story buildings.
See, two stories is very expensive to build. And high rise is like I don't like high rise. I reckon it should be banned. You shouldn't have it. It's like a skyrocket slum eventually. I mean, here in Perth, the average
there's tasteful ways to do it.
No, there's plenty of land. I mean, in Perth, we got millions of acres of land. I mean, it's just that the government controls it all, and the banks control the government. See, the banks don't care about the interest rate. They just care about the land going up, because that's the biggest expense anybody spends their money on, is land. That's your biggest expense. And they want it to double. Usually land doubles in value every like 7 years. So just think about it. The interest rate doesn't matter. I mean, the interest rate could be 4%. You know, when I started my business 37 years ago, I was paying 20% on my overdraft. 20%. I was getting 17% on money in the bank. You know, now even if it's 4%, doesn't matter. But that land now it's like my father's place. It went from £54. Now it's 1.5 million, and the 3 houses on it wouldn't have cost. Now they would probably cost about 450,000 to build. Banks don't. They don't really care about the interest rate. It's that if the land doubles in 7 years, you're not lending out $50,000, you're lending out $100,000. So your interest rate, you know, the amount of money doubles. And they haven't got the money. They haven't got the money. They're just printing it.
Yeah, sooner or later that system's going to go down. It's only a matter of time.
Well, this is the problem. They go, you know, like it's back in, when was it? 2000 to 2006. In Perth, industrial land went up 6-fold in 6 years, and residential land went up 3-fold in 6 years, and just blew everybody out. But the banks still lent money for people to buy houses, and but in Australia we had a lot of people coming from England. Like there was something like, I think the number was like 1,500 people were emigrating to Australia every week from England. Like where I lived.
Sydney's full of palms.
Yeah, palms. Yeah. Where I lived,
Sydney, just about all palms.
Yeah, they're everywhere. They're in all government services. Anything government is either is POMs. All you get now is like Pakistanis and Indians. They're all driving the trucks around, delivery vans. They're all Pakistani, nearly the whole lot.
Yep, same here.
Yep. Like back in 2000, we were where I lived. The house across the road, the bloke that built it, right, was from England. He sold it. He sold it to some people that were from England. They sold it, and they sold it to some people who came over from Sydney, and they were from England, and they came over here, didn't like Perth for some reason. I don't know why you would pick Sydney over Perth, but they were only here about 12 months and then went back. They sold it to some people from Ireland, right? And the bloke from Ireland, he sold his house in Ireland, got like 500, I think it was £500 or £600, which is like double in Australian dollars. And he bought a house across the road for $500,000, and he had another $600,000 in his pocket. You know, I mean, and my house, my wife just sold it for $1.1 million in one day. Like, this is about 12 months ago. She sold it in one day for $1 million. They put it on the market on the Sunday and sold it. And they had like four people chasing it in one day. And now it's probably worth about 1.3, 12 months down the track. I don't know where you can get $1 million from. Like, you know, it's yeah. We're in deep shit.
Yep. The you know what is gonna hit the fan soon, and like I was saying before, nobody seems to notice what's going on. Everyone's just moseying on down, doing their thing, and yeah, it's gonna be something. The
Oh
future
yeah,
is
it's.
gonna be something.
I mean, I don't know. I can't afford to buy a house for $1 million. I'm lucky I own everything, but I got divorced. That's why she sold it. Had a nice house and she sold it. But we got big problems. And when you're talking about like young people on, you know, antidepressants, my son's girlfriend, she was 18 when the doctor put her on antidepressants, and she was on it for 4.5 years.